All right, I hope you guys had an awesome weekend. So, welcome back. Today, we are going to talk about confidence intervals versus hypothesis testing and how they relate. We have technically talked about this before 2 units ago when we did hypothesis testing with proportions. Now, we're just going to talk about it with hypothesis testing with means. So, in the past unit, we've actually already talked about this. For hypothesis test, you fail to reject the null because the hypothesized value is considered to be reasonable. Okay. And when we decide that the null is rejected, that means we're saying that hypothesized value is not reasonable. For a confidence interval, that a value will be contained in the interval if it is a reasonable or plausible value. And when the value is outside the interval, that's considered unreasonable. And we talked about that in both of our confidence interval lessons when we did it with proportions and means. So the way that this all relates is that if you reject the null hypothesis, so if you reject the null hypothesis, that's saying you're not reasonable, which means that it should be outside the confidence interval. So the confidence interval will not contain the hypothesized value. Where if you can't reject the null, that means that the confidence interval will contain the hypothesized value. And that's a big conclusion that's made comparing confidence intervals to hypotheses. So let's go ahead and flip the page. So on page 9 are our examples we're going to work through today. So on page 9, our first example, we have the ability to rearrange desks in an elementary classroom is instrumental to create learning groups that enhance the learning environment. A company that produces desks for elementary use claims their desks weigh 2.6 pounds. We have actually done a hypothesis test about this. We wrote the null as the mean is equal to 2.6, and the alternative was claiming that their desks weigh more than 2.6 pounds. But in that test, we failed to reject the null hypothesis. So if we fail to reject the null hypothesis, that's going to relate to our first question. Will the confidence interval contain the hypothesized value of 2.6? Well, if you fail to reject the null hypothesis, that means that it's plausible. So since the null hypothesis was failed to be rejected, $2.6 is a reasonable value. So it will be within the confidence interval. So remember, if it's a reasonable value, that's exactly what a confidence interval is showing you, all the plausible values for the population. Oops. Okay, and just to prove this to you, in case you didn't believe it, they gave us some data to calculate the confidence interval, and we are ever so closely approaching that final exam. So let's review how to find this confidence interval just to prove that it is within it. So remember, for a confidence interval, you're going to go to stat, test, but remember, we want a one sample t interval, so you just go to t interval, which is number 8. This one they give me these stats for. So I have my x bar of 2.58, a standard deviation of 1.5, and a sample size of 50. If you don't believe this data, look back in lesson 3. We did cover this. The confidence interval is 0.90. So if I calculate that, I get a confidence interval of 2.224 to 2.936. And what do you know? 2.6 is within that. Now, where it's at within that, it doesn't matter. Even if it was 2.225, that's good enough because it's within the confidence interval. So 2.6 is within the interval. And that's just proof, right? You're not going to have to do that, but it's just to show you, like, look, this is for real. This happens. Okay, so let's do another example. Example B. So we have a 90% confidence interval for the average daily intake of calcium for a random sample of 40 teens is given. For teens, the recommended daily allowance, which is RDA, of calcium is 1,300 milligrams. So we're going to write hypotheses that would test, so that would test if the calcium intake of these teens is below the recommended allowance. So the null hypothesis, you have to assume that they are going to get the average daily recommendation of 1,300 milligrams. But the alternative is that we want to show that it's below the recommended allowance. So that's going to be that mu is less than 1,300. So based upon the confidence interval, will the null hypothesis be rejected? We don't even have to do a full hypothesis test. I will to prove it to you, but we don't even have to do a full hypothesis test to figure this out because I have the confidence interval. Since I have the confidence interval of 970 to 1145 essentially, let's see, 1,300 is not within that. So since 1,300 is not within, so I'll start putting this in words. So since 1,300 is not within the confidence interval, it is an unreasonable value. So remember, confidence interval is telling you what is reasonable or plausible for that problem. So since 1,300 is not within that, we cannot say that's a reasonable or plausible value for this problem. So it's not reasonable or plausible, that means the null will be rejected. So HO will be rejected. And once again, just in case you didn't believe that, we could actually perform this hypothesis test. So in letter C, it was calculated on a random sample of 40 teens from a large high school that had a mean daily intake of 1,057.1 milligrams of calcium with a standard deviation of 323.4 milligrams. So let's see if I go to stat, test, and then t-test, because now I'm doing a hypothesis test. I have the stats. The hypothesized value is 1,300. The mean is 1057.1. Standard deviation of 323.4 with a sample size of 40. And the hypothesized value, they said they were trying to see if they got below the recommended allowance. So if I hit calculate, I get a t-test statistic of negative 4.750 and a p-value of 1.373. So once again, since the p-value is greater than alpha, oh, I just realized I typed what, we need to reject this, right? But I just missed something. It's 1.373 e negative 5. So it's times 10 to the negative 5th, which is essentially 0. That's definitely less than or equal to alpha. Right? So that just means you move the decimal place 5 times over. So it's 0.00001. So since the p-value is less than or equal to alpha, we would reject the null hypothesis. And that's just proof that you would reject the null hypothesis in favor of the alternative. All of this also works for two-sample hypothesis testing. So it is going to work for both. I'm going to go ahead and stop this video, and we'll pick up in the next video. So see you guys in that one.